Alright, hello, this is Jeffrey Chung, and today I'll be covering the topic of real numbers, and it's all from Algebra 1. Yeah. So the first one, classifying the real number. So basically, real numbers can be divided into two groups, rational numbers and irrational numbers. And inside the category of rational numbers, there are three more little things, which is integers, whole numbers, and natural numbers, as you can see over here in the graph. So yeah. So first we'll be going over the topic of natural numbers. So it's basically numbers we use for counting, and we describe them in the set of notation as 1, 2, 3, and then it goes on forever, where the ellipsis, this sign, indicates that numbers continue to infinity. And over here you can see the number line of natural numbers. They start from 1, and then 2, 3, 4, 5, 6, 7, 8, 9, and the arrow here indicates it's going to infinity, so it never stops, but it starts from 1. Yeah. An example we used in real life includes when we enumerate the members of this team, and also counting the coins in a collection. Moving on to the next slides, we got whole numbers. So basically, whole numbers are all natural numbers plus the number 0. Notice that the natural numbers start from 1, not 0. So this is a number line of natural number. Start from 1, goes on to infinity. And this is the number line of whole numbers, just 0 plus the natural number line. So it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes on to infinity. So all natural numbers are whole numbers. Yeah. And since whole numbers are basically natural number plus 0, natural number plus 0 is equal to whole number. Yeah. Moving on to the next slides, we got integers, and this is the set of integers adds the opposite of natural numbers. So natural numbers start from 1 and it goes on to infinity. The opposite side of natural numbers is basically starting from -1 and it goes on to negative infinity. So the set of whole numbers could be expressed as starting from negative infinity and then -3, -2, -1, and then we got 0 over here, 0, and then 1, 2, 3, 4, 5, 6, and then it continues to infinity again. It's useful to note that the set of integers is made up of 3 distinct subsets. The negative integers, which is everything from the left side of 0 and 0 itself, and also positive integers, which is basically everything from the right side of 0. Yes. And then the next one we got rational numbers. Rational numbers, like the set of rational numbers, is written as m over v, where m and n are both integers, and n cannot be 0. So let's move on to the graph, not the graph, just the thing over here. So the m on the top is called numerator, which is the number on the top, and the n on the bottom is denominator, which is numbers on the bottom. And notice that the thing on the bottom, the denominator, couldn't be 0, because else it would be it couldn't be defined, because you couldn't have 0 on the bottom of the integer, not the integer of the number. You couldn't have 0 on the bottom. So rational numbers are fractions with integer on both the numerator and the denominator, where the denominator couldn't be 0. It is pretty important. So because they are fractions, any rational number can be also expressed in decimal form, and any rational number can be represented as either a terminating decimal, which is a number with finite decimal representations. For example, 1.8, 2.12345, 470.91, where the number ends at 1, the number ends at 5, and the number ends at 8. And also we got the second one, it's repeating decimal. So for example, 0.55555, where the 5 is repeating, and also 0.1212121212, where the 12 is repeating over and over again, and it continues to repeat. It never stops, which is different from the finite decimal representation, where it stops at 1, 5, and 8. So the next one we got irrational numbers, and it's like the number cannot be written as fractions of two integers. So examples of irrational numbers are, like for example, this set of number 0.337468850 322667923, and it continues at a random pattern. It's not repeating and it's not stopping at a specific number. So this is irrational number. And also pi, where it's around 3.14159, and it goes on. And again, it's not following a specific pattern, so it's not repeating. And then again, it's not stopping at a point since it's continuing forever, so it's also an irrational number, same as these two. Square root of 10 is around 3.16227766617, and then it continues in the random pattern. Also E was around 2.71828182846, and then again it continues at a random pattern. It's not stopping at a number, and it's not in the specific pattern, so again it's an irrational number. Yeah. So the last one, we got the real numbers, and the set of rational and irrational numbers together make up the set of real numbers, as you can see over here. Like rational numbers plus irrational numbers is like makes the real numbers up. Yeah. So as we saw with integers, the real numbers can be divided into three subsets: the negative real numbers, the zero, and the positive real numbers. So as you can see over here in the real number line, you can see 0 is over here. Negative real numbers are any numbers that's less than 0. So basically everything starting from here, like the tiny bit less of 0 to the negative infinity. And the positive real numbers are basically, again, just flips the side, everything that's bigger than 0. And each subset includes fraction, decimals, and irrational numbers according to their algebraic sign, plus or negative. So basically, if you got a positive sign, or sometimes just no sign in front, then it means that it should be, when it's placed in the number line, real number line, then it will be somewhere like not 0, but somewhere bigger than 0. So it should be on over this side, like starting from here to anywhere else in this side. And if you got the negative sign, it's the same but the other way. You could be everywhere in here, in this side. Yeah. And notice that 0 is considered neither positive nor negative. So 0 over here, it's not positive and it's not negative. Yeah. And let's do some practice question. Write integers as rational numbers. Write each of the following as a rational number. So I'll be giving you guys 30 seconds to work on the 3 questions over here, starting from now. Okay. Alright, so time's up, and the answer for these are 7 over 1, 0 over 1, and negative over 1. It's basically just putting a 1 on the denominator, which is still the same, and yeah, just make it rational number. And practice question number 2. Identifying rational numbers. So write each of the following rational numbers as either a terminating or repeating decimal. And I think you can use your calculator or anything for your calculation on these questions. And since it's a bit harder than the previous one, I will give you 40 seconds to work on these questions. Alright, so the answer for these questions are negative 0.714285 and 714285 are repeating, so it's a repeating decimal. And the second one, when you simplify it, you basically get 3, or you could express it as 3.0, and it's a terminating decimal because it stops at 0 or 3. And for the third one, 13 over 25, you get around 0.52, sorry. And it's a terminating decimal since it stopped at 2. The third question, differentiating rational number and irrational numbers. So determine whether each of the following numbers is rational or irrational. If it's rational, determine whether it is terminating or repeating decimal. So since it's 5 questions, I'll give you 50 seconds to work on these questions, starting from now. Alright, so here are the answers. The first one is rational, because when you simplify it, you get 5. And the second one, 33 over 9, it's rational, because it's a fraction of integers. You got an integer 33 on top, and also an integer 9 on the bottom. So, and then if you round it, you will get 3.6, where the 6 is repeating. So it's a repeating decimal. Yeah. And the third one, the square root of 11, it's irrational because you can't express it as fractions of integers. And the fourth one, 70 over 34, it's rational because when you simplify it, you get 0.5, which is a terminating decimal. Yeah, because it stops at 5. And the fifth one, although it seems to be an repeating decimal, but it's actually not. So it's an irrational because it has neither a terminating or a repeating decimal. Because it's, and here the ellipses again, like show it's continuing forever to infinity. And the last question, classifying real numbers. So classify each following numbers as either positive or negative as and has either rational or irrational. Does the number lie to the left or the right of 0 on the number line? So I think it shouldn't be too hard, and I'll give you guys about 30 seconds to work on these. Starting from now. And alright, so here are the answers. Oh wait, here's the number line just to make it better for you guys. And here are the answers. The first one, it's negative because it got the negative sign in the front of the numbers, so it's negative. And it's also irrational, since it's irrational, but even though like it's both, there are both integers on top and at the bottom of the number, but it's irrational because when you calculate it, you get some numbers that's not repeating, and it goes on forever. So it's irrational, and it lies on the left of the 0 on the number line since it's negative. And this one is positive, and it's also irrational, and it lies on the right side of the 0 on the number line since it's positive. And yeah, since it's positive, but although it didn't express, like it didn't put the positive sign in front of the number, you have to know that it's positive because there is a negative sign in front of that. So yes, that's how you identify where it should locate on the number line. And the third one, we got negative square root of 289. It's negative, and it's also rational, since when you calculate that, you will get negative 17, and it lies over here like negative 17, so it should be somewhere over here, and it's like left of 0 on the number line. And then the fourth one, we got negative 6 pi. We talked about pi before, and we know that it's irrational, so anything times irrational number is still irrational. So here we got negative, and it's irrational. Again, it lies on the left side of 0. And the last one, we got 0.615384, 615,384. It's positive, and it's also rational, since the 615,384 is repeating. And since it's positive, it lies on the right side of the 0 on the number line. Yeah. So I hope you get all these, and this is my lesson today. So thank you for listening. Yeah.